All right, we've looked at how to graph a circle if it's written in standard form, but if it's not in standard form, we have to be able to change it. And it turns out that our skills that we learned last year in algebra when we learned how to complete the square come in very handy when it comes to this next section on circles. So I want to spend one day just reviewing completing the square. And in order to do that, we need to really back up and just review multiplying binomials. So remember we did this when we were solving quadratic equations back in algebra. And something that's quadratic could be solved a multitude of ways. One way to solve it would be to graph the quadratic function and see where it hit the x-axis. Another way to solve it was by factoring using the box, and we would come up with two binomials. And once you had those binomials, let's just say it was a x and a 2 and a x and a -3, then it was equal to 0, and you would use the zero product property to solve. Of course, the quadratic formula, x equals opposite b, works in any case. We also could solve by taking the square roots of both sides, say if you had an equation like that, but you have to remember to do plus or minus square root, and then there was completing the square. And most people, you know, it wasn't their favorite technique, but it's not that bad, and you really have to be able to do it for the next lesson on circles. So here we go. So backing up, doing this really quickly, but you guys already know how to do this. So I'm asking you to multiply, and at first glance, that might not even look like a multiplication problem. But remember, this means to take 3x minus 1, and we've got two factors that are identical, and to multiply it by itself. So we could use the FOIL method where we multiply the first terms together, the outer terms together, the inner, and the last. We learned that last year, and we also learned to do it with the box, okay? So we have a 2 by 2 box, we have a 3x minus 1, and another 3x minus 1. So in this box, 3x times 3x is 9x squared. 3x times the minus 1 is a -3x. 3x times minus 1 again is a -3x. And then, of course, the negative times the negative is always going to give us a positive. So if these binomials are the same, anytime you multiply something times itself, you get a perfect square. Anytime you multiply something times itself, you end up with a perfect square. And then these two boxes are always going to be identical to each other. There are going to be two of them. I just want you to keep that in mind. So when we multiply these together, the answer we get for number 1 is a 9x squared, writing it in descending order. We have a minus 6x's when we combine those, and then we have a positive 1 because we multiplied a -1 times a -1 to give us a positive, okay? All right, so the same thing here. We've got a binomial and we're squaring it. It means to multiply the 5a plus 6 times itself. And again, if you want to use the FOIL method, if you want to just distribute through, that's perfectly fine. I'm just going to stick with the box because it's pretty visual. All right, so in this first position, we're multiplying something times itself. I end up with a perfect square. In this final box, 6 times 6 is going to give me 36, which is also a perfect square. In this box, 6 times 5a is 30a. 5a times 6 is 30a. Once again, those two are identical to each other, all right? They repeat. So I have two perfect squares, and then two monomials that are identical. And so basically you can just double 30a, right, to get 60a when we write our final answer. So we have a 25a squared, we have two 30a's, so that's 60a, and then we have a 36. So it starts with a perfect square, it ends with a perfect square, and the square root of this, what number times itself gave us that? That was 5a. What number times itself gave us 36? That was 6. If you multiply 5a times 6, if you multiply those two things together, you end up with a 30a. And if you double 30a, you get 60a. Okay, that's always gonna be the way the things kind of play out whenever you have squared a binomial. All right, so let's factor. So I'm starting with a trinomial. Now this is the easiest kind to factor because the leading coefficient is a 1. So I can look at this just really quickly, and I know the two things that multiply to 10 that add to 7 are 5 and 2. I could factor this in my head, no problem. But I just want to stick with our box and remind you how we factored last year. So the leading term is the x squared. My constant term is a 10. They go here and here. The 7x is going to get split between these two boxes, okay? So we know that these multiply together to give us a 10x squared. I need to put two numbers in this box that would multiply to 10x squared and add to 7x. So we're looking for two things that multiply to give us a 10x squared and add to give us a 7x. And I think you can see that 2x times 5x would work. 2x times 5x is 10x squared, and 2x plus 5x is going to give us 7x. So a 2x and a 5x. And then we're just going to fill in the edges. So what times what would give us x squared? Well, we know that would have to be an x times an x. And x times what gives me 5x, x times 5. X times what gives me 2x, x times 2, and then just check it. Do 5 times 2 give us 10? They do, so I factored it. It factored into an x and a positive 5, an x and a positive 2. Okay, so it factors into an x plus 5 and an x plus 2. We're just using the box in reverse order. All right, so let's do this one. In the upper left position, we put our leading term. In the lower right, we put our constant. So we know that these two things multiply together to give us a 16x squared, but we want them to add to give us a negative 8. So they're going to add to give us this and multiply to give us that. Can you think of two things that multiply to 16 and add to 8? Hopefully 4 and 4 pop into mind, but we want this to be positive and this to be negative. So a positive 4x times a positive 4x would work, but it wouldn't add to give us that negative 8 that we're looking for. But if they were both negative, a negative times a negative gives us a positive, and that would work. So both of these are the same. So notice, perfect square, and these two things are identical. That tells me that this is going to factor like these first two problems that we worked. We call this a perfect square trinomial because all of those conditions were met. It factors into let me just do that really quick. So x times x is going to give us x squared. That x would need to be multiplied by a negative 4 to give us this. This x would need to be multiplied by a negative 4 to give us that. And negative 4 times negative 4 would give us positive 16. So those are our two binomials. We have an x minus 4 times an x minus 4. And of course, we can just write that once to the second power. So how could I know that without going through that lengthy process? Well, I know x times x gives me x squared. That's a perfect square. 4 times 4 gives me 16. That's a perfect square. So we said x times x and 4 times 4. If I multiply x and 4 together, I get 4x. If I double that, I get a positive 8x, not a negative 8x. But I could make this work if the two numbers that multiplied together to give us 16 were a negative 4 times a negative 4. Still gives me a positive 16, but now it results in a negative 8. Anytime that relationship is true, you know you're dealing with a perfect square trinomial, and it's just going to factor into a single binomial to the second power. Again, you know all of this. This is just a reminder, but this concept is really important when we complete the square and work with our circles. So let's factor these faster, because I can't help but notice that is a perfect square. 3x times 3x would give me a 9x squared. That's a perfect square. 2 times 2 would give me 4, and that's positive, so I don't have to worry about any negatives here. If I multiply 3x times 2, I get 6x, and if I double that, I do indeed get 12x. This is a perfect square trinomial, and these are the two terms that go in our binomials, a positive 3x and a positive 2, and that's going to get multiplied times itself. So we know we can just write that once to the second power. All right, let's look at this last one. So is it a perfect square trinomial? And I'm sorry, this is a little crowded, so just try and focus. Just number 6 here. 49x squared is a perfect square. 7x times 7x. So is 9. 3 times 3 would give us 9. If I multiply 7x times 3, I get 21x. If I double that, do I get 42? Yes, but not a negative 42. But we can fix that if we use a negative 3 times a negative 3 to get our positive 9. Now the 21 is negative, and when we double that, we get a negative 42x. So those are the two terms in our binomial. It's going to factor into a 7x minus 3 times exactly itself, so we can simply write that once to the second power. Okay, so now that we've reviewed the perfect square trinomial, what value of c, remember anything that's quadratic, if you write a quadratic function in standard form, it's ax squared plus bx plus c, c's are constant, what value of c would result in a perfect square trinomial? All right, it starts with a perfect square, yes? What times itself gives us x squared? Just an x. I know that I'm going to multiply that by the square root of this number, and when I double it, I want to get 10x. Well, if I double 5x, that would give me 10x. And in order for this to be 5x, this would need to be a positive 5. And the square root of what number would result in 5? That would need to be a 25. C would need to equal 25 in this case in order for it to be a perfect square trinomial. Okay, same thing here. This is a perfect square, x times x. That's going to get multiplied by this value in order to give me, after I double it, it's going to give me a negative 12x. Well, if I double negative 6x, I could get negative 12x. So this needs to be a negative 6. And negative 6 times itself would result in a 36. So C would need to be 36 there. Okay? All right. Perfect square, yes? X times x. I'm going to multiply x by some number, and when I double it, it's going to result in a negative 22x. Well, half of negative 22 is negative 11x. So I've got the x, so this number is negative 11. And if I turn around and I square it, negative 11 times negative 11, this number would need to be 121, which is a perfect square. Okay, all right, last one. Does it start with a perfect square? Yes. What's the square root of this? 4x. I'm going to take the square root of this number to end up here. All right, we know that 4x is going to get multiplied by this value. And if we double it, we want to get 40x. So what do I double to give me 40x? It needs to be 20x. So what does 4x need to be multiplied by so that we get 20x? It needs to be multiplied by a 5. And if I go back the other way, right, I square 4x to get 16x squared. If I square 25, I get 25. C would have to be 25 in that case. All right, so how did we use all of that? What was the point? Well, we could solve these quadratic functions by completing the square. So here's what we do. Sometimes I said we would just kind of kick out the c, but when it equals 0, I know the c needs to end up on this side. This is a perfect square, and I want to make this a perfect square trinomial. Right now, the square root of 9 is 3, and x times 3 doubled would give me 6x, not 8x. That's not a perfect square trinomial. So here's what we do. we group up the x terms, and we'll go ahead and we're going to take this c and we're going to move it to the other side and make it equal 9. Again, you know how to do this, so let me just review. Now, we just practiced coming up with this c value, right? This is a perfect square. X times x gives me x squared. I know that that's going to get multiplied by some number so that when I double it, I get 8x. Well, half of 8x is 4x. And this then would need to be a 4. And 4 is the square root of whatever this number needs to be. So this number is going to be a 16. So I added 16 to the left. I can't do that. That's illegal. I just made the left side heavier. So in order to balance this equal relationship back out, I need to add 16 to the other side. Now, let me remind you how we did this last year. In order to come up with this number, all you do is you take this and you cut it in half. Half of 8 is 4, and then you square it. You took the b value, you cut it in half, and you squared it. That's where the 16 came from. Half of 8 is 4, 4 squared is 16. All right, I know this is a perfect square trinomial. I know it's going to factor into the same exact two binomials, and these are the two terms that will be in my binomial, an x plus 4 and an x plus 4. And that's equal to, on this side, we end up with 25. Okay, well, the whole reason we did that is so we could write it once to the second power. Okay, now I'm trying to solve. And honestly, I could stop right here, you guys. We don't really need to remember how to do the rest of this for circles. We needed to be able to get about that far, creating the perfect square trinomial, but I might as well finish. So if you're gonna solve, I'm trying to solve for x, but x is stuck inside these parentheses. This quantity is being squared. So I need to undo that operation to free it up. But if I take the square root of the left, I have to take the square root on the right, and I have to remember plus or minus square root, okay, because there's two numbers that would multiply to give us positive 25. So the square root undoes the squaring, and out pops x plus 4, and on this side we get a plus or minus 5. How do I get x alone? I want to subtract 4 from both sides. So x is going to equal, I either have a positive 5 minus 4, or x would be a negative 5 minus 4. I'm subtracting 4 from two different numbers over here. So x is either positive 1 or negative 9. And if we were to graph that quadratic function, it's a parabola, it would hit the x-axis at those two values. Okay, very quickly, I do need to do this one. And it's because it's the first one we've seen where this is not a 1. I've got a number here other than 1. How do we handle this? Well, the first thing we're going to do is take the c and move it over. This is not currently a perfect square trinomial because that's not a perfect square. All right, so we're going to group up our x's, and then I'll go ahead and move this over to the other side. Okay, so this is now equal to negative 11. But I need this to be a 1, not a 4. So what I'm going to do is factor it out. We're going to pull the 4 out and write it out front, but I'm dividing it out of everything, okay? I'm doing the distributive property backward. So that leaves me with an x squared plus, if I divide that by 4, I have 6x, and that's equal to a negative 11, okay? I want to make this a perfect square trinomial. Well, it starts with a perfect square, x squared. So in order to find out what I want to add here, I'm going to take half of this number, half of 6 is 3, and then I'm going to square that. 3 squared is 9. This is now a perfect square trinomial, but I didn't just add 9, I really added 4 times 9. So I made this side of the equation heavier by 36, so I'm going to need to add 36 on this side to keep things balanced. All right, so we have 4 times, this is going to factor. What times itself gives us x squared? X times x. What times itself gives us 9? 3 times 3. And both of those need to be positive in order to get that positive 6x. And over here I get 25. Okay, so I have 4 times x plus 3 squared equals 25. Let's go ahead and get rid of the 4. I'm going to divide both sides by 4. Now, I usually stick with fractions, but this is a pretty nice decimal in this case. We end up with 6.25 when we divide. So let's just go ahead and deal with the decimal. And now when I take the square roots of both sides to undo the squaring, I have plus or minus the square root of that. So on this side, out pops x plus 3. On this side, I get a plus or minus 2.5. So we're going to subtract 3 from both sides. So what am I doing? I'm subtracting 3. I have a positive 2.5 that I need to subtract 3 from. So that would leave me with a negative 0.5. And then I also have a negative 2.5. Negative 2.5 that I'm subtracting 3 from, and that's going to give us a negative 5.5. So those are the two solutions there. All right, that was review. Try the practice problems yourself, and then watch the solution video to see how you did.